So welcome everyone. This is lesson number 4 on probability, and all we're going to do today is we are going to start with this question over here. This is a Venn diagram and it has 3 events. Oh, we move that off to here. And in this Venn diagram, you need to tell me, you need to answer these questions. So I'm going to hit mute all, and if we look at this Venn diagram, there's a circle for C, there's a circle for W, and a circle for B, which is cycling, walking, and buses. And we didn't do this last time, or did we do this one last time? I don't think we did. So let me know in the chat. Maybe we did some of it. Okay, so how many items are there in this Venn diagram? Or N of S, I'm just going to add them up. 26 plus 15 plus 20. Do you all get 162? Give me a thumbs up if you get 162 for the number of items in the sample space. Okay, we're off to the races. Then, students, there are 162 people in our Venn diagram. You need to find me the probability. Okay, you don't have to be in the simplest form. What's the probability a randomly chosen person walks to school, comes by car, uses a bicycle? I want you to try and answer all of these questions using this Venn diagram. And I just want to see you can interpret. Okay, let's so for the first one, walks, how many are there in the circle? It's going to be 15 plus 17 plus 19 plus 18. So that is, there's a 69 out of 162 chance that someone walks to school. Let's do comes by car. I want to see those answers in the chat. What's the chance they come by car? Welcome to Mateo and Naledi and Ganlin and Simamkele and Tamia who are with us, and Bukhle has also joined us. It is good to be with all of you. So comes by car, we'll just be adding up all the items in the car circle. Now, some of these people also come via other measurements, but this is going to be 80 out of 162. And then you can kind of see for bicycle, I'm just going to add up. So for the bicycle, I get that. So we've done this one here, but now the question gets a bit trickier. It says, what is the probability that a randomly chosen person only walks to school, or walks only? So now that's a slightly different question. You're not allowed to take another mode of transport. Does not walk at all is another type of question. And then walks or uses a bicycle. So now they're starting to use words like not and other fancy things. Where would walks only be? I think these are the walks only people. So the sample size is, well, the sample space is still that. So it's 17 out of 162. Does not walk. Ooh. Now, does not walk, we would sort of, in fancy notation, we say dash. So you're not allowed to be any of the people in yellow. That's the hint I'll give you. You're not allowed to walk to school. But everyone else is invited to this probability party. So what's the answer for that going to be? 26 plus 20 plus 22 plus 25. I get 93 people do not walk to school. And so the probability of getting one of those people is going to be 93 out of 162. If they ask for decimals or percentage, follow the question. But for now, I'm not going to go into anything extra. Okay, last one for the warm-up. Walks or uses a bicycle. So now you can be in the yellow, or you can be over here as well. I do enjoy some coloring in sometimes. So I want to know, what's the probability of getting someone who walks or uses a bicycle? Okay, what are we getting? 20 plus 19 plus 15 plus 18 plus 17 plus 22. I'm getting 111 as my total, but for it to be a probability, it's going to be 111 out of 162. Okay, give me a thumbs up if you followed that first question Venn diagram. I want to do one more, and then we must move to tree diagrams. But just give me a thumbs up if you are with me. Okay, now, if you get a question like this, it's wonderful because you don't have to draw anything. But sometimes we have to draw. So here's an old exam question, and we're going to do this together. So it says, a survey was done among 80 learners on their favorite sport. Okay. It says the results are shown below. Here's a whole bunch of things. You need to draw me a Venn diagram to represent this. So I'll give you 2 minutes. When you are done drawing your Venn diagram, say Venn in the chat, or say V for Venn. So off you go. I'm going to give you 2 minutes until 11 minutes past 5. See if you can draw a Venn diagram from this old exam question. I love the answers coming. Thank you, Callan, Ganlin, Simamkele, Pufunzo, Sanako. Yeah, thank you. Keep those answers coming. And we're going to draw ourselves a Venn diagram here. Now, this is important. Ex-learners like all 3 types of sports. So we're going to have the interlocking circles. And I'm going to have R for rugby, V for volleyball, C for chess. And I'm going to put an X in the middle of all of these. Now, you still need to fill in the other regions. When you have completed your Venn diagram, please put a V in the chat so that I know that you have had a chance to think through this and do this question. I just want to give everyone a chance because this is literally the type of question you're probably going to get in your tests. And so I want you to have a chance to think it through. Okay, that's a bit small, but you get the idea. So I'll give you 1 more minute, then please put a V in the chat if you're done. I've done the middle bits, but we've still got to fill out the other parts. Okay, now what is this? Then if you don't know what to do, just have a look at what I'm doing on the board. So we've got 26 minus x. All right, everyone. If you look at the board now, you will notice that I have x's on the board. Give me a thumbs up if you agree with my Venn diagram. Okay, fantastic. Now, next question for 2 marks. Show that x is 8. I would love someone to tell me, how do I suddenly solve for x? What piece of information do I still need to grab from the question? What's the piece of information that's going to help us finish this? It is the 80 over here. And so what you're going to do is you're going to say 80 is equal to all of this stuff. 3 plus 26 minus x plus 12 plus 14 plus x. Let's see that I've done them all here. 14x that plus 20 for these two plus 13 minus x. And where have I got? Got 20 plus 13 minus x, and then that will be, and you'll solve for x. And if you solve this thing for x, you will get x is equal to 8. Okay, now we're going to move on because today is more about tree diagrams, but just to show you how this would work, let's do one more question here. How many learners like only rugby? So look at your Venn diagram and you're allowed to use the fact that x is 8. How many learners only like rugby? What is the answer going to be if you look at your Venn diagram here? And then we can move on. So we're looking for the rugby circle, and the people that only like rugby are over here. So 26 minus x. And we know that x is 8. So the answer here is going to be 26 minus 8. So it's 18 students. So 18 students only like rugby. Okay, everyone, that is, I'm going to leave Venn diagrams for now, but just give me a feel in the chat with a squad of 10. How do you feel about Venn diagrams at the moment? Give me a squad of 10 for how you feel about Venn diagrams. They are a very common test question. I would love to get a 10 out of 10 if you understand it perfectly, 0 if you feel lost, 5 if you're in the middle. How did we get the 13 minus x? What we did was we took the 42, which was how many students liked volleyball, right? And we went minus what are the other ones in the volleyball circle. So we have a 14, a 15, and an x. And so we go minus and we get that, which gives us 13 minus x, which is this bit. Did that help? Okay, let's go to Sanako, whose hand is up, and we can have a question there. Hi, Sanako. How can I help?
So when we do the Venn diagram, so do we start from the bottom of the question and then go up?
You don't always have to do that. You could go, well, okay, this is the way I do it. I look for the one that's in the middle, right? So when it said X learners like all 3 types of sport, I did that one because then I know the 3 circles have to overlap, okay? And then I put the X in the middle. Then I said, okay, well, this one, 3 learners don't like any sport. That was the next one that I did. And then you're right. I would say you work from the most specific. So in this case, most of the time it's easier to work from the most specific at the bottom to the least specific at the top. Thanks, Sanako. That's actually a really good point. Did everyone get? Let's give Sanako a thumbs up or a hand clap if you understood the question, because like it makes a lot of sense to go from the most specific stuff at the bottom to the least specific at the top. Okay, awesome. Thank you. See, this is why students asking questions helps other students. So I really appreciate that one. Okay, so in this land of probability where we are quantifying uncertainty, the Venn diagram is the one way we have of expressing what's going on. But there is another diagram that we have to begin to master, and it's a rather sudden just jump across. But basically, let's have a look at a tree diagram question. So, tree diagrams, what are they? Tree diagrams are very useful for solving probability problems where the events are independent or where the events are dependent. They're actually useful in both cases. Now, I'm going to show you an example of how to do one, and then you're going to do one by yourself. So let's read this question together. They often have stuff about marbles and drawing things out of hats and stuff. So it says, a bag contains 6 blue, 5 red, and 9 white. A marble is drawn and replaced, and another marble is then drawn. So you have a situation where you take something out, you then put it back, and you take something out again. And the choices you have, there are 3 different choices. You can have a blue marble, you can have a red marble, or you can have a white marble. Now, what is the most likely color? What is the color that you're most likely to get? Because these marbles are not equally likely. One is more likely than the other. What color are you most likely to get? Callan, you've nailed it. Bukle, you've nailed it. Because the white, there are more of the whites. Now, to take this into account, what we do is we say, look, how many marbles do we have? We say 6 plus 5 is 11 plus 9. In total, we have 20 marbles. But the chance of getting the white one is higher than all the others. So what I'm going to say is I'm going to write the probability of getting the white marble on the tree. What's the probability of getting a red marble? Well, it's 5 out of 20. And what's the probability of getting a blue marble? It's going to be 6 out of 20. So what we do with our tree diagram is we write the probabilities of each of the outcomes on the tree. Give me a thumbs up if you understood the way I put my outcomes at the end of the branch and the probabilities on the branch. Give me a thumbs down if I lost you. Okay, now here's the problem. We don't just draw it once. We draw it a second time. So how are we going to represent the second draw? Well, because we put the marbles back in, we can have the same choices as before. We can have blue, we can have red, or we can have white. We could have, oh, I should have used that one. So the second time we draw, we have exactly the same choices as the first time. So I'm going to put, in fact, I'm not going to use the same colors every time. You guys can kind of understand what I'm doing. Now, when I look at the branches of my tree, because I put the marble back in, this is still going to be 6 out of 20. This is still going to be 5 out of 20. This is still going to be 9 out of 20. Give me a thumbs up if you understand why the branches still have the same probability. Okay, so I've lost some of you. Now here's why. It says the marble is drawn. So you draw it the first time. I'm picking up my marble, okay? I take it out, and then I put it back in. How many marbles are now sitting inside my hat, or whatever it is that it's sitting in? I'm still going to have 20, because if I took one out, and then I put it back in, you get 20. But now how many things inside this thing? There are 9 white ones. So there are 9 white ones. There are 5 red ones. I realize I should have used the right colors, but anyway. And there are 6 blue ones. So in this case, what you're choosing from hasn't changed. So when you draw a second marble, you've still got a 6 in 20 chance of blue, 5 in 20 of red, and so on. Give me a thumbs up now if you understand why the second time I draw, it's the same. Give me a thumbs down if you still feel a bit lost. Okay, don't worry. If you are a bit lost, I'm going to take you through this example, and we'll do another one after this. So what I'm going to say is each of these branches, so let's just do the last one. Blue, 6 out of 20. Red is 5 out of 20. And then this last one is 9 out of 20. Now, all this is doing is it's describing me choosing twice from the hat, but with replacing. What is the actual question? So it says determine the probability that both marbles you draw are white. So basically what they're saying is, what are the chances you take something out, you choose one of these ones, you take it out, you put it back, and you choose it again. Now, I want you to look at the tree and see if you can identify the pathway that has 2 white items being chosen. So I'll say W, W for white, white. Can you identify the tree path or the branches where you get white and white? So I think it is, well, I don't think, I know it's this one because there's a W here. So I get 9 out of 20 chance that one. And then to get it again, there's a 9 out of 20 chance here. So how do I use my tree to help me get the probability of getting white and then white again? Ladies and gentlemen, the glorious news is that you simply multiply each branch together. And so the chance of getting white and then white again, given these conditions, is 81 out of 400, which in decimal land, 81 divided by 400, that would be 20.25% chance. So there's 20.25% chance that you will get white and then white again. Now, that was a bit of a tricky one, and so I want to give you a chance to do another one like that. So before I move on, I'd like to ask, are there any questions from the class or things you'd like me, or anything you want to clarify before I give you another example? Notice how I had 2 branchings because you chose twice. Okay, let's do this again. The easiest way to get this is do it like this. So let's look at this question. It says, a bag contains 5 red counters. So I'm actually literally going to draw 5 red ones. And it has 3 yellow ones. Okay, I don't have 3 yellows, so I'm just going to put Y for yellow and R for red. Have I got too many reds? I think I do. 1, 2, 3. I should only have 5. Okay. It says a counter is picked at random and then replaced in the bag. So I take one out, but then I put it back in again. And then I do this again. I want you to draw a tree diagram for the situation. So I'm going to give you a minute and see if you can draw a tree diagram that represents this situation. I'm not even going to ask you a question yet. I just want to know, you are picking something out, putting it back, picking it again. Can you draw a tree diagram for the situation? And I want you to, when you've had a chance to put a tree diagram in there, I want you to put D for done in there. I'll give you a little hint. How many choices are there? There's yellow. So yellow, and there's red. What are the chances of getting a yellow? Write it on the branch. What are the chances of getting a red? Oh, but you have to do this again. You have to do this again. So now the question is, what are you going to write on those branches? See if you can do this. Welcome, Njabulo. I see you joined us during the lesson there. We're just doing tree diagrams. So how many in total? We have 8 things inside, so 8 in total. What's the chance of getting yellow? It's 3 out of 8. What's the chance of getting red? It's 5 out of 8. Now, because you put things back in, what's the chance? Well, what are the options going to be here? They're going to be yellow and red, and yellow and red. And what are the chances of getting yellow? It's still 3 out of 8. It's 5 out of 8 chance of getting red. Here, it's still 3 out of 8. And here it is 5 out of 8. Now, I want you to give me a thumbs up if you've understood the tree diagram now, and give me a thumbs down if you still feel a bit like, yeah, I'm sort of, okay. So I think we're feeling a bit better. This is good. Okay, now it's time to do some questions, ladies and gentlemen. So I want you to work out for me. We're not going to do all of these. We're just going to do some of them before our break. What is the probability that I get a red counter first, followed by a yellow counter? Can you work out the probability of that outcome happening? I'll give you a moment or two to work out what's the probability of getting a red followed by a yellow. Okay. Now we need to make sure we have the right pathway. So what does it mean to get red? Well, that's what the big R is there for. It's to help us. But I'm not allowed to get red on the second go. I'm going to get yellow. So that's the pathway. And in terms of writing it out, it's red and then yellow. So I'm going to go 5 over 8 times 3 over 8, which is 15 over 64. So that wasn't too bad. Can you please do for me now, what is the probability of getting a yellow counter followed by another yellow counter? So you need to get, what's the chance of getting a yellow, putting it back, and then getting another yellow? Ask yourself, which part of the tree are we on for the yellow? I think it's this pathway here. So excuse me writing things everywhere, but I think I'm getting better at this. And it feels like it should just be 9 out of 64 for this one. This one was 59. You know what? You guys are doing so well. Let's do these last two as well. What are these last two? So we'll call this, yeah, we've got number 1, number 2. We've got 2 more, and then we're going to take a break. So the probability that a yellow counter was picked first, followed by a red. Let me just write this down so I don't confuse it. So yellow and then red. So yellow, 3 out of 8, red. So this is 3 out of 8 times 5 over 8, because I went yellow and then red. And that is also 15 out of 64. So that's the chance of getting that happening. Now, what about the last one here? What is the probability that a red counter was picked and then a yellow, or a yellow counter and then a red? So there's this word or, which seems to alter the calculation. See if you can work that one out. I'll give you a little bit of help. So what they're saying is, what is the probability of getting red and then yellow, or the probability, well, basically this, what are the chances of getting this? Let me write it like this. Probability of RY or YR. Boucle, you have got this correct. You add them together. Yes, you do. So this last one, what is the probability of getting red, yellow? We know it is 15 over 64, but because there's an or, okay, we are going to add, what is yellow, red? Yellow, red was 15 out of 64. And so what we're then going to get is we're going to get 30 out of 64. So basically, all you needed to do was you needed to add the two branches together. So this was, you get the answer for the one, you get the answer for the other, and you just add them together. And you get 30 out of 64. Okay, I think it's time for a break, but just give me a score out of 10 for how you felt about this last example. I know I went a bit quickly there, but it felt like you were getting better. Give me a score out of 10 for how you feel about tree diagrams so far. All right, now the good news is we're going to do more after the break, so you don't need to stress if we're not quite there yet. Gannon's asked, do we need to simplify answers? If the teacher says yes, if the question says simplify, do it. But for today, I'm just practicing on teaching you guys. Okay, but you know, too much work and not enough play means your brain doesn't get a chance to recover. So we need to take a moment for our brains and take care of our brains. So can we please all step away from our desks or our tables or our beds? And we're just going to have a quick little break. And I'm going to tilt my camera up so you can see me. And let's just take 3 deep breaths. So breathe in. Breathe in. Shake it out. Shake out your legs. Okay, and then the jumping jacks are going to get the blood pumping. So in 3, 2, 1, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3 more. 1, 2, 3. Oh, and I can feel my heart pumping. Is your heart pumping? Let me know with your emoticons. Is your heart pumping, or are you just in shock? Where's the shock emoticon? There we go. All right. I think part of my heart's a bit like, okay, easy with the last ones there. Okay, everyone, it's time for you. Should we do that one? Actually, let me get another one here. Okay. We're not going to be replacing yet. So we're going to look at this situation, but I'm going to change the question. It says a ball is drawn at random and then replaced. Then another ball is drawing. Oh, no, that's fine. Okay, let's do this one. Here we go. We're ready for this. Over to you guys. You've got 2 minutes to draw your tree, and I want you to try and answer this question for me. You're flying solo here. You can do it. I believe in you. Let's go, Amakhalanga. I know you can do this. Akwande, you've got this. Machadiso, we're ready to roll. So when you've got your answer, you can just pop it in the chat. So the pathway that I see being red is 12 over 17 times 12 over 17. So 12, let's look there, times 12 over 17. And that's 144 over 289. And if we're comparing, sometimes decimal is easier. So let's go with 0.498. Or in, oh, flip, what happened there? Come back. 49.8% chance of getting red and then red. What is the chance of getting, I'm going to make up my own question now. What is the chance of getting, what's the probability of getting red or blue? This is my remix edition question. Can you figure out for me what is the probability of getting either red or blue? One would imagine it's higher, because remember, so this is basically saying, I'm happy if I get red, or if I get blue. Both of those are favorable events. What is the chance of getting either of those? Or, yeah. Yes, Anako. So if you are looking at, so for example, this question, what is the probability that both balls are red? You say, look, that's the chance of getting red on the first throw. That's the chance of getting red on the second throw. And so we just multiply those two probabilities. Now, what's different about my remix question is that is one good pathway, but we could also go that pathway. And so what is the probability that we get either of these? That's the question. Now, if I think of what we did last time, didn't we just add them together? And we already have the red one. It's 144 over 289. Now, what would the blue one be? I think it's just 5 over 17 times 5 over 17. Because that's what this branch does. So let's do that. 5 divided by 17. squared, and then I get 20, so you get 144 over 289 plus 25 over 289. And so what you're going to get there is you are going to get the chance of that happening is 169 over 289. Or and you could put that into decimals. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow it. Okay, so there are a couple of different, mostly up, but there are some down thumbs. So all I do is if there's an or, I can have two different branches and I just add them together. Okay, that's all we need to do. Now, what I'm going to do in the next question is things are going to change a little bit because I am now going to take the ball out, but I'm not going to put it back in. What do you think is going to happen if I choose the first time, I take something out, and then I don't put it back in and I choose again? Are the numbers going to stay the same? Like previously in these questions, the first choice and the second choice kept the numbers the same. Are the numbers going to stay the same if I don't put them back? No. You'll have one less ball in the hat, which means that the numbers have to change. And this is called drawing without replacing. So you don't replace. Things change. So let's do one example with me doing it and then you do it. Okay, it says, consider a jar containing 7 red balls and 4 blue balls. So let's do my 7 red. 1, 2, 3, 4, 5, 6, 7. Then I've got 4 blue. 1, 2, 3, 4. Now, when I draw, I'm drawing twice. So I think all of you will agree, or give me a thumbs up if you understand why my tree looks like that. My first choice has 2 choices and my second choice has 2 choices. Now, what are those choices? Well, I can have red or I can have blue, and I can have red or blue or red or blue. So that part of the tree is not hard. What's hard to keep track of is what are the probabilities on the branches. And the other thing is this part of the tree is the first draw. This part over here is the second draw. Give me a thumbs up if you understand why you understand that this part is the first draw and this part is the second draw. Okay, now, when we start, I want to ask you, what is the probability that I'm going to put on this branch over here? What is the chance of getting red on the first draw? So in total, there are 4 plus 7, which is 11. And how many of them are red? Well, 1, 2, 3, 4, 5, 6, 7. There's 7. So there's a 7 in 11 chance of getting red. What is the chance of getting blue? There is a 4 in 11. In fact, let me use a different color, otherwise it's going to get confusing. Let me stay with black. So this is 7 out of 11. This is 4 out of 11. Okay, but now I'm going to take one of these balls out. How many balls are going to be left inside the hat if I started with 11 and I took one out? How many balls are left in the hat to draw from? So I'm taking one out. I don't know what it is, but I'm reaching in and I'm taking one out. There were 11. There are only 10 left. So you know what? Whatever probability comes next, they are all going to be out of 10. Right? Because whatever I put in here, there's only 10 left in the hat. Give me a thumbs up if you understand why I'm only going to be out of 10 now. Okay, now, assuming I chose a red on the first go, right? So I'm on this pathway. If I took out a red on the first, how many reds are left out of those 10? So basically, I chose red. I'm starting at the top. I've got 10 left. How many reds are left inside the hat? Well, because there were 7 to start with, and I took one out, this is going to be 6 out of 10. All right. Now, imagine I took a red out. How many blues are left? How many blues are left for the second go? So there were 4, but I only took a red one out, so there's still 4 out of 10. So that's why there's a 6 in 10 chance for red, 4 in 10 chance for blue. Okay, but now we have to go to the bottom. If I chose a blue on the first go, so that's B for blue, how many reds are left here for my second go? How many reds are left in the container if I chose a blue on the first go? Well, I didn't touch any of the reds, and so there will be 7. All right, now I chose a blue one. How many blues are left for my second one, my second choice? Well, there were 4 to start with, but I chose a blue one, so this is 3 out of 10. Okay, so now you have your tree diagram for a situation where you weren't replacing the balls. And the biggest thing that stood out to me is that the 11 went down to 10, and each of these numbers went down by 1 if they were chosen in the branch before. But if they weren't chosen, they stayed the same. So I want you to tell me, what is the probability of choosing a red one on the first go and then a red one on the second go? I want you to use your tree diagram. What is the chance of choosing red, not replacing it, and then choosing a red again? What do we think the chance of getting a red and then a red again? Use your friend, the tree. Trees are your friends. Give the tree a hug. It will help you, I promise. So I look at the pathway that corresponds to choosing the red, and then I look at choosing a red again, and I feel like I've got this. It's 7 over 11 times 6 over 10, which is 42 over 110. Or if I want to write it as a decimal, I could write it as 0.38 rounded off. Okay. Or 21 out of 55 is also fine. Figure out the next one for me. What's the chance that the first ball is red and the second ball is blue? Please figure that one out for me. What's the probability of getting red and then blue? So I'm using a different pathway. So red and then blue. 7 out of 11 times 4 out of 10. So I've got 28 out of 110. Okay. All right. Now, this last one is a little bit sneaky because they use this word at least. One of the balls is red. So what they're saying is any of the ones where the ball is red will be fine. So I will give you, this one is a good pathway. This one is a good pathway. This one is a good pathway because they all have some red in them. What is the probability of getting that? So what's the probability? Yeah, Simon Kele, I'm coming to you. What is your question? Can I help you out?
I think you made a mistake with the probability of getting red and blue.
Let's have a look. Red and blue. Red is, are you happy with the 7 out of 11?
Yes, sir.
Okay, so the red ball, 7 out of 11 were good. Then it says the first ball is red and the second ball is blue. What's the chance of getting blue? I would say 4 out of 10 is the chance of getting blue. Are you happy with that?
Yes, sir.
Okay, so then 7 out of 11 times 4 out of 10. Let me just check my calculator. 28, 11. No, I stand by this. I don't know if maybe, yeah, I'm pretty confident. Can you show me an area where you think it went wrong?
So I put it in the calculator and I get 14 over 55.
Okay, but it might be simplified. So let's have a look. So 28, oh, it's equivalent. It's an equivalent fraction. So we got the same thing. But thank you so much for your comment. So everyone, this is important. There are different ways of it being written. And so all of those ways are right unless the question says do it this way. Okay, for the last one, let's get this. So it's going to be 7 over 11 times 6 over 10 plus 7 over 11 times 4 over 10 plus, what was the last bit? The other one with red in is this one. So that is 4 over 11 times 7 over 10. Can someone give me that final answer? Can someone give me that final answer? So when I add the branches, I'm getting 1. So should we always get 1? Yes, Pavunzo. The reason you get 1 is that you must get one of the choices on the tree. So Pavunzo's asked, if I add up all the choices on the tree, I get 1. And that's because these are the only options. So there's 100% chance you will get one of the branches. That's why when you add them up, it adds to 1. Does that help, Pavunzo? Does that make sense? Okay, let's get our final answer for this one, and then I think we can call it for the day. You should be getting, if it's simplified, 49 out of 55 chance. So there's a very high chance you will have some red in your life. Okay, Bukle, what is your question?
So I just saw Sir like do the calculation. I didn't see like what the question was. Like you made P and then you made brackets. So what was supposed to go in there?
Okay, so the reason I put brackets in, and so, Pabunzo was asking a question about why all the branches add up to 1. Is that what you're asking about, Bukle?
Oh no, so I mean for the third question for B, Sir
Yes.
made like a P and then he made 2 brackets. I don't know what was supposed to go inside. We just saw you
Oh,
erasing and
okay.
then
No, so for the third one, you would just put all the choices that are relevant. So it would be RR or RB or BR, because those are the 3 choices that have some red in them.
Okay, thanks,
Okay.
sir.
Pleasure.